we probably don't know about 90% of the species that exist. We look at what we call myofauna, which are small, tiny little organisms. You can't see them with your eyes, but that's where a lot of the diversity of life actually exists, and we know very, very little about them.
I want to look at the roles that those bacteria play in their ecology and their adaptations, especially in the marine sediments we're looking at, which are marine sediments that have been impacted by the Deepwater Horizon oil spill in the Gulf of Mexico.
And so what I do is I try to understand what these communities look like, to understand the diversity and understand how this oil is actually impacting them.
The Hubbards were key. Their support for the establishment of the Genome Center was just fundamental. When the Genome Center was established in 2001, I think it was a prophetic move. I think we established early on that investment paid great dividends. Our ability to attract external funding because of the instrumentation and the facility and support that came with the establishment of the Genome Center was just incredible.
Kind of the backup in a lot of the scientific world and genetics and whatnot is actually trying to analyze the data that we generate. So using machines like the Illumina HiSeq here, we generate long strings of things like A, T, C's, and G's, so our genetic code. And so on the computer, I'm actually trying to decipher that and kind of to look for trends and analyzing big data.
One of the really valuable things about an institution like UNH that has this dedication to undergraduate research is that we're supporting faculty research programs at the same time providing training for students that when they leave here, they're ready to step into laboratories for graduate school, for example, or into industry. They're trained in doing things that are not just theoretical and not on decades-old instruments.